Suppose we have to find the integral of 5x plus 3 over x squared plus 2x minus 3. First thing we should look at to see is if we find the derivative of the denominator, if it is a multiple of the numerator. Because if it is, it's a simple u equals the bottom line, and just substitution will fall out in about 3 or 4 lines. So if this was like 5x plus 5 on the top, when you find the derivative of the bottom you get 2x plus 2. 5x plus 5 is a multiple of 2x plus 2, so by letting u equals the denominator and do that substitution, find du dx and then do the substitution for dx, you'll find that a lot of things will cancel out and then it'll be just left with the integral of 1 on u du, and so you can work it out. This is not the case, so we have to come up with another technique, and that's called partial fraction. So we need to split this into its partial fraction. So before we can do the integration, let's split this here into its partial fractions, and we do it like this. We go, alright, we've got to factorise the denominator first, so we've got x squared plus 2x minus 3. I've always taught the cross method. Factors of x squared are x and x. These two numbers we've got to multiply together to give you negative 3. So there's only factors of 3 and 1. Now this negative here tells me that these are going to be opposite signs. So I don't know at this stage which one's positive and which one's negative. When I multiply along the arms and add, so if I multiply along there I get 3x, multiply along there and I get 1x. When I add, and you always add those two together, I have to get the middle term. Now I know that these signs are opposites, and I know I've got to get a positive. So if I make that a positive there and that a negative there, when I add positive 3x to minus 1x, I get positive 2x. So the plus goes in front of the 3 and the minus goes in front of the 1. So brackets around the top, brackets around the bottom, so that's equal to x plus 3, x minus 1. So now I can write 5x plus 3 over x squared plus 2x minus 3 is equal to 5x plus 3 over x plus 3 over x minus 1 equals a over x plus 3, the first one, plus b over x minus 1. Our next step is to be able to calculate what a and b are. So all we've done is factorise the denominator, kept that as it is, and then just split it up into some expression over x plus 3 plus some expression over x minus 1. Now we've got to find these two expressions. And how do you add partial fractions? If you go back to one of the previous little lessons I did, we actually make the denominators the same. So we've got a over x plus 3. To make the denominators the same, we multiply top and bottom by x minus 1 plus b over x minus 1. To make it into the same denominator, we're going to multiply top and bottom by x plus 3. So we've got this is equal to that. So if the denominators are the same, we can then combine them into one fraction and we'll have that plus that all over that one because they are the same denominators. So we can equate the numerators. So we've got 5x plus 3 is equal to a outside of x minus 1 plus b outside of x plus 3. And the reason for that is that the denominators are the same, so the numerators must be the same. Now there are two ways of doing this, and I'll just do them very, very quickly. I'll do both. So the first method involves because you've got x minus 1 and x plus 3, let x be a value here to make this equal to 0, and then the a will be, all this term here will be equal to 0. So if we let x equals 1, we substitute for 1 in there, and we've got 5 times 1 plus 3 is equal to, if we put x equals to 1 there, you've got 1 minus 1, 0, 0 times a is 0, so all of that is gone. So you've got b outside of 1 plus 3. So 5 ones are 5, plus 3 is 8, so we've got 8 is equal to 4b. So b is equal to 2. And then the next thing, so we've made x equal 1. It'd be nice now if we've got a value for b, if we made all of this term equal to 0, so x equals negative 3. Substitute in for negative 3 up here, and we've got 5 times negative 3 plus 3 equals a outside of negative 3 minus 1. So 5 times negative 3 is negative 15. Negative 15 plus 3 is negative 12. Is equal to negative 4a. Divide both sides by negative 4 and we get a equals 3. So we got b equals 2 and a equals 3. So that is one approach you could do. You wouldn't use both, but I'll just show you the other way now. If we multiply out, we've got 5x plus 3 is equal to ax minus a. So just multiply out using the distributive law, plus bx plus 3b. Now get the terms containing x together. So we've got x outside of a plus b. And then we've got minus a plus 3b. Now if you've got 5x plus 3 is equal to a term in x minus a constant term, then the coefficient of x must be the same. So you've got 5 is equal to a plus b. And so the constants must be the same. So the term in x must be the same, and the constant term must be the same. And so you've got 3 is equal to minus a plus 3b. Here we have simultaneous equations, two unknowns, so we can solve. By simply adding these two equations together, we get 3 and 5 is 8, minus a plus a is 0, 3b plus 1b is 4b, and that will give us, divide both sides by 4, you get b equals 2. Having got 1, we substitute back in one of these equations, so if b is equal to 2, 2 plus a equals 5, so 5 equals a plus 2, and that will give a value of 3. So we got the same values, two different approaches. Which one do you use in which situation? It'll be purely up to you. Some people will feel happier doing it this way, some people feel happier doing it with simultaneous equations. So now we've got the integral of 5x plus 3 over x squared plus 2x minus 3 dx is equal to the integral of we've split the fraction here is to a over x plus 3 plus b over x minus 1. And we've found that a is equal to 3, so it'll be the integral of 3 over x plus 3, because a was equal to 3, dx, plus b is equal to 2. We'll do it in two parts. 2 over x minus 1 dx. That's not needed. Okay, so we've split it into its partial fractions. These then are much easier to integrate, and that's equal to 3, the integral of 1 on x plus 3 dx, plus, bring the 2 out the front, 2 integral 1 over x minus 1 dx. The integral of 1 over x plus 3 is ln, so 3 ln of x plus 3 plus 2 ln x minus 1 plus our constant of integration. So that's integration by partial fractions. Don't confuse it with integration by parts. It's very, very different. Just going back over it again. If the the denominator is factorisable, we do it. We then split it into its 2 linear components, and we have a and b on the top. Our task then is to find a and b. We actually combine the fractions together by making the denominators the same. So in this case we multiply top and bottom by x minus 1, ex plus 3. And then because the denominators on both sides here are the same, we can equate the numerator. 2 methods for finding a and b. One is by making this equal to 0 by putting x equals 1, and then making that equal to 0 by putting x equals negative 3. That's one method. An alternate method, so these are or, one or the other, you don't do both, is to get all the x terms together and all the constant terms together. You equate the coefficients of x, not x itself, leave it out of it. The coefficient of x has to be the same, so there's the coefficient, there's the coefficient. 5 equals a plus b, and then equate the constant terms. You'll set up 2 equations, 2 unknowns, and then you'll be able to solve for a and b. Either way gives you the same value. So then when we integrate each of the partial fractions individually. Constant terms as the numerator can come out the front, and then 1 over x plus or minus something is just ln that, whatever that denominator is. And then don't forget your constant of integration as well.